Hi, it's Mrs. Lowe. This is the video on Chapter 2.8, Solving Absolute Values, Equations, and Inequalities. You guys have already done the team challenge, so we're going to move right down into the lesson, which is on solving compound inequalities and writing and solving absolute value inequalities. So first we're going to fill in the words. A compound statement is made up of one or more equations or inequalities. So down at the bottom you can see some examples of some compound statements. A disjunction uses the word or, and the solutions go in opposite directions. Hence, the solution satisfies either statement. They do not have to satisfy both. It could be a solution if it works for one of them. Versus a conjunction uses the word and the solutions overlap. Hence, the solution must satisfy both statements. If it only satisfies one, it's not a solution to the compound statement. So we're going to go down to A and B. A is a disjunction because of the word or, so the shading will most likely go in opposite directions, not always. And we solve these the same way we have been solving inequalities. We get x is less than 3, and we get x is greater than or equal to 6. We also do our shading the same way we've been doing it. 3 open circle to the left because x is less than 3, and 6 closed circle to the right. So any number, any rational number to the left of 3 is a solution, and any number from 6 and beyond is a solution. Either one would work. As an interval notation, we would write it like this. That should be a bracket right there next to the 6. Let's start that again. This U means union. It's another word for or. So the solution is here or here. If it falls in either, it is a solution. Versus B is a conjunction. It has the word and. In order for it to be a solution, it has to satisfy both of these equations or these inequalities. So I'm going to solve this first one. You get x is greater than or equal to -3. And this one we have to divide by -1. So the inequality sign flips over. You get x is less than 4. So now we're going to graph this, and I'm going to do 2 different colors so you guys can see the overlap. X is greater than or equal to -3. Well, here's -3, we'll say, closed circle, and the shading would be to the right. Versus x is less than 4. 4 is somewhere over here, open circle, and the shading would be to the left. But the solution to a conjunction is where they overlap. So the solution is actually from -3 all the way up to and not including 4. So the solution is where they overlap. So using interval notation, it would be parenthesis or bracket -3, 4. So those are conjunction statements, and the reason we solve those first is because when we solve absolute value inequalities, we have to create conjunction statements. But first we're going to start with absolute value in equations. So let's do a quick review of absolute value equations and what absolute value is. Absolute value is written with the little bars on either side. So A could be anything, it could be a number, an expression. And basically this means whatever is in the center there is the distance from that to the origin, or 0. It's a distance. And that's really important because distance is always positive or non-negative. So the absolute value of something is got to be positive. This A would always be, the output would always be positive. So for example, the absolute value of x is 4. It says what values are 4 units from the origin? Well, there's 2 values that are 4 units from the origin, -4 and 4. So x could be either one of those. Both of those are 4 units from the origin because the absolute value of -4 is 4, and the absolute value of 4 is also 4. So when we solve an absolute value equation, we're actually going to set up two equations. We're going to set the term, the expression inside the absolute value equal to the positive a, and we're going to set that term and equal to the negative a. So we're looking right here because absolute value could be, the number inside could be negative or positive because when you take the absolute value, it is positive. So we're going to do this example together, and then I want you to practice A and B, and then I'm going to stop the video for the second part will be on inequalities. So the first thing you're going to do when you're solving these is you always isolate the absolute value expression. Think of this absolute value expression as its own variable. So you're going to isolate the absolute value expression. Never, ever, ever distribute into absolute value. Never do that. These are not parentheses. You are not to distribute. You want to just keep this together, and you're going to isolate the x plus 1, the absolute value. We're going to isolate this. So I'm going to do that by adding 6. So I get 2 absolute value of x plus 1 is equal to 10. And then to undo the multiplication, I divide both sides by 2. So this is isolating the absolute value. Okay, so I've isolated the absolute value expression. Done. Now I'm going to split into two equations, because remember, this can be equal to positive 5 or negative 5, because they're asking what is 5 units from the origin, and the expression is x plus 1. So some number plus 1 is going to be 5 units from the origin. That means x plus 1 could be equal to negative 5, or x plus 1 could be equal to positive 5. So we split the equation into two problems, and we put an or between it because it can be one or the other, and it's a solution. So now I just solve each one. I move the 1 over by subtracting it. I get x is negative 6. I move the 1 over by subtracting it, and I get x is 4. So the absolute value of x plus 1 equals 10 has two solutions, negative 6 or 4. And when we plug that back into the original equation, we're going to see that indeed true. So all I'm doing is plugging in negative 6 for my x into the original equation, or I could use the simplified equation. This would give you the absolute value of negative 5 is 5. Now I could multiply it by 2, and I get 10 minus 6, which is indeed 4. So this is just showing you a check that it works. I'm going to do 4 now. Absolute value, 2 times the absolute value of 4 plus 1 minus 6 is 4. I'm just showing you that both of these work. Absolute value of 5. Absolute value of 5 is 5. Once you take the absolute value, it comes out of the absolute value symbols, and 10 minus 6 is 4. See how both of those work. So this is a solution. Both of these are a solution. One or the other would work. Now I want you to try A and B, and I'm going to stop the video, and on the beginning of the next video I'll have the solution, and then we'll move on to absolute value inequalities.